Hey guys, back here with our videos from section 3.3, going through and looking at proofs of the derivatives of the trig functions. And if you've watched the first video, you saw that we had to do a couple of limits to do some groundwork so that we could actually do the proof that we're trying to do, which is the proof that the derivative of what the derivative of the sine of x is. Or in other words, we need to prove that the derivative of the sine of x, excuse me, we need to prove that the derivative of the sine of x is equal to cosine of x. Okay, so my starting point is just, I'm going to start off with the derivative of the sine of x, and I'm going to go with my good old definition of what the derivative is. And if you've had too much Christmas and can't remember, here it is. Do the derivative of f of x, we do the limit as h approaches 0 of f of x plus h minus f of x all over h. And if we do that limit, that is the derivative. So I just took that and plugged that in here, okay? So that's going to be kind of the starting point. I just said, oh, let's just literally use our good old definition. We're going to push the car and see where it goes. Now, to do this, you notice that we have this sine of x plus h, which we need to expand. And you might want to believe that the sine of a plus b is equal to the sine of a plus the sine of b, which would make life really easy. Unfortunately, it is not true, and I can easily show that it's not true. So do not file this away in your head. It is bad. You don't do it. It's not true. Now, unfortunately, many of you probably have not seen this trig identity just because of COVID is taken away some of your trig training here. But I'm going to tell you that in this case, the sine of a plus b is really going to be the sine of a times the cosine of b plus the cosine of a times the sine of b. And it's an easy, again, a relatively easy identity to prove. It's just that this isn't a trig class. So I'm not going to prove it here. So you're just going to have to accept that this is not true, but this one is true. And we're going to need that to expand this down here, okay? So that's kind of a starting point. So need that, and we need to know the definition of the derivative, which we have, okay? So where am I going to go from here? Well, I've got that limit. So the first thing I'm going to do is try to find my pen. There it is. Now I'm going to find my little thingy. There it is. And I'm going to move that out of the way here. So the first thing I'm going to do with this problem is simply break this single fraction into two separate fractions. So I'm going to go through and say, okay, this is the limit as h approaches 0 of the quantity, the sine of x plus h all over h, and then minus the sine of x over h. Okay. So nothing magical going on there. I took a single fraction and broke it down into two separate fractions. Okay, fractions. Okay, and in fact, I should probably have moved this a little bit closer so that it is not taking up. Whoops! Don't do that. Come back here. Come back. Okay. What I want to do is see if I can scoot this over. Probably not. Okay. Now I'll just put it down below. Okay. So now I'm going to, I want to be able to see, I'm going to do it right here. We'll see what happens, okay? So now next step here, I'm going to go through and say, okay, it's live television. I'm going to go through and use this to expand. So I'm going to throw, this is going to be equal to the limit as h approaches 0. And I've got this, now I'm going to expand out my first fraction. So I'm going to do this sine of x plus h. So that is going to be the sine of x cosine of h plus the cosine of x sine of h. And that's still all over h. Simply going through and using that identity up here to break it apart. And then the second one is still going to be equal to the sine of x over h. So just going through and doing the expansion on the top there. Okay? The next step is basically to do a little bit of work with changing things around here. Mainly because of the fact that they all have the same denominators, I could break this into a couple different fractions, and I can switch the order a little bit. That's the cool thing about having the same. Now I can do this in a couple of steps. I could rewrite this as a single fraction over h, change the order, then split it apart again. But I think you can see what's going to happen here. So I'm not going to do that. Basically what I need is, I need this sine of x to be with this sine of x, and this to be over there. So I'm going to basically move that around. So when I go through and do that, I'm going to get the limit as h is going to approach 0 of the quantity, and then I'm going to have the sine of x cosine of h, and then I'm going to go minus the sine of x from right there, and then this is all going to be over h, and then it's going to be plus, and then what's left is going to be the cosine of x sine of h all over h. So just doing a little bit of manipulation algebra there, but doing it in a couple different steps, okay? So just basically switching the order around, a little commutative property, essentially, right? Just to show that all, I'd have to do about 4 steps, but I think you can see where it's coming from there, okay? So next step, well, again, the reason I wanted to do this is because now I have a common factor in this numerator of the sine of x. So if I wanted to now, I could go through and say this is the limit as h approaches 0, and then on the top here I'm going to get the sine of x, and that's going to be times the cosine of h minus 1, and then this would be all over h. So just removing the common factor of the sine of x there. Good? Okay? Now, looking at this one, I can split it up similarly. I'm going to go through and split this one up as being the cosine of x times the sine of h over h. Now, if you're significantly clever, you see why I did this. Because this thing and this thing looks like what we saw in the previous video. Okay? So now I'm doing the limit of this thingy, right? Well, it's a limit of a sum. So then I can do the sum of the limits. So I can take the limits of each one of these. But then those are products. So I can do the limits of each one of those. So basically now I can break this down doing my limit laws. So Brooke would really appreciate this. So Brooke, if you're watching, this is one's for you. I'm going to break this down doing a couple different steps with the limit laws here. But essentially what we're going to end up with here is we're going to break this apart into the limit as h approaches 0 of the sine of x, okay, times the limit as h approaches 0 of the cosine of h minus 1 over h, plus the limit as h approaches 0 of the cosine of x, and then that's going to be times the limit as h approaches 0 of the sine of h over h. So basically using all my limit laws and breaking that apart, okay? Well, some of these are going to be very easy. Well, actually, they're all very easy because this limit and this limit are dependent upon h, and there's no h in there. So that means that the limit as h approaches 0 of this is simply going to be the sine of x. So it's going to be the sine of x times something. This limit is going to be, as h goes 0, it's just going to be the cosine of x. So we got those in there. That's going to be times something. Well, we just saw that if we do the limit as h approaches 0 of the cosine of h minus 1 over h, we just saw on our previous page, if I go back there and go down, we saw that that limit is 0. And that other limit is going to be equal to 1. So now I can go back here and say, yep, I can now say with 100% certainty that this limit here is going to go to 0. This limit here is going to go to 1. So in the end there, what is this going to be equal to? Well, the sine of x times 0 is 0, plus the cosine of x times 1 is the cosine of x. Cosine of x plus 0 is going to equal the cosine of x. And I just showed that the derivative of the sine has to be, by definition, the cosine of x. And there is your proof, right? But again, this proof goes nowhere. This proof really goes nowhere if A, I don't know some trig identities, which I had to throw in there, and B, I had to have this limit and this limit. Without these two limits, this proof is kind of dead in the water. But I found those limits in the previous video, found them here, and you can see that, hey, this is not really that terribly difficult. I just showed that the derivative of the sine must be the cosine. And we can use a similar type of proof now to go through well, we wouldn't even have to do that. I mean, we can use the fact, we now know that the derivative of the sine is the cosine, so now when we go to prove the derivative of the cosine, we can use that fact, and this actually becomes a simpler problem. And again, I'm not going to go through and do that because it actually, if you look in the book, it'll do it, but this is the more important one because you need these two limits and to see that this is true. Okay? So there is your proof of the derivative of the sine of x being equal to the cosine of x. Again, using a couple limits that we had to kind of massage our way around. Okay, all right. So there's that. Now I'm going to come back with one more video. In that video, we're going to look at a couple other things. We're going to look at a proof of the tangent. We're going to look at the cotangent and probably the secant, if I remember right. So in the next video, we're going to do 3 more. But all of those become much easier now that we have this groundwork already done. Okay, so the next video will probably be I'm going to do 3 of them, but they're going to go pretty quick there. Okay, so stay tuned for that next one.